Okay, here's warm-up 8.1, and we're going to rewrite this equation in vertex form. Okay, so one way to do this would be to find the vertex and kind of write the equation from that. But I'm going to do this by completing the square. Okay, so I'm going to try to form a perfect square trinomial over here. So I need to find a mystery number that's going to make this a perfect square trinomial. It's not going to be negative 12. So I'm going to move the negative 12 out of the way by adding 12 to both sides of the equation. So I'll just have x squared plus 16x over here. Okay, and then I'm going to want something added to get that perfect square trinomial that factors into something times itself. Okay, and that whatever I add to this side, I have to add to the left side of the equation as well. Okay, so there's a little formula to find that number to make a perfect square trinomial. This is going back a little ways, but it's going to be b over 2 squared. So the b in this trinomial would be 16. 16 over 2 squared, so that's 8 squared, which is 64. So 64 is that what I call the mystery number, okay? And since it's going in there, it has to go in here as well, okay? Now, the right side of this equation, you could do a diamond problem if you like, but it's going to factor into something times itself because 8 plus 8 is 16 and 8 times 8 is 64. So this factors into x plus 8 times x plus 8. I'm going to write that as x plus 8 squared though because I'm going to be completing the square, okay? And then I'll combine the 12 and the 64. Okay, and now this is almost in vertex form. All I have to do is subtract 76 from both sides. And now it's in vertex form. And, oh, then it says, then find the vertex. Well, the vertex would be negative 8, negative 76. So, set the contents of the parentheses equal to 0. X would equal negative 8. And then that's my y value as is. And there's the vertex. Okay, so I'm going to complete the square again on this this next problem, and since it has a coefficient in front of the x squared, I'd want to take care of that first. So I'm going to divide the whole equation by 5. Sometimes doing division like that will leave you with some fractions that you have to deal with, but lucky for us, it doesn't here, right? 5 goes into everything in this equation. So now I've got 0 equals x squared minus 6x plus 11. Okay, so this equation is equivalent to the original one, and it's a lot easier to complete the square with. So I'm going to move the 11 out of the way because that's not my mystery number, and I am going to be adding a mystery number to both sides. Okay, and just like on the last problem, I'm looking for a perfect square trinomial. So I'll do b over 2 squared. Here b is negative 6. So positive 9 then is my mystery number. Okay, on the left side I've got negative 2. On the right side this is going to factor into x minus 3 times x minus 3, also known as x minus 3 squared. Okay. And now that I've got this, the right side is something squared, the whole point is now that I can take the square root of both sides to start to isolate x. So when you take square root of both sides of an equation, don't forget there's a positive and a negative root. This side's just going to be x minus 3. Okay, and then I'm trying to get x by itself. So I'll add 3 to both sides. I'll put the 3 in front of the plus or minus. Okay, and then this is an imaginary number, square root of a negative, so I'm going to write that as I root 2. And that's what x equals. Okay. All right. Another old problem here. We're going to write an equation in slope-intercept form. So slope-intercept form is y equals mx plus b. So that's the format I want my final answer in. Okay, so we're writing an equation for a line. It goes through this point. It's perpendicular to this line. So I like to set this up with what I call my old line, which is the 4x plus 5y equals 2. And the new one's the one that I'm going to write the equation for. And first thing I want to do is find the slope of this new line. I can do that because these are perpendicular. So I'm going to find the slope of the old line first, and that will lead me to the slope of the new line. So I'm going to put this in y equals mx plus b form, because if I do that, the m is the slope, right? So let's see. I'll subtract 4x from both sides. I could write 2 minus 4x, but I'm going to put the negative 4x in front of the 2, just so it's in this format. Okay, and then I'm going to divide everything by 5 to get it in y equals form. Okay, and now I can see that my old line has a slope of negative 4/5. Perpendicular lines are going to have opposite reciprocal slopes. It won't have the same slope. That's if they were parallel, but perpendicular, I flip this upside down and change the sign. So positive 5/4 would be a perpendicular slope to negative 4/5. Okay. Then I also knew this went through the line negative 2, 3. Okay, so that's everything I know about the new line, and that's enough to start writing the equation. So I'm thinking, okay, y equals mx plus b. Well, I already know the slope is 5/4. Okay, I still need to find the b, so it's going to be y equals 5/4 x plus or minus something. I need to figure out what the something is. And that's where this xy pair is going to come in, my through point. I'm going to plug that in for x and y, and then I should be able to solve for b from there. So I'll put 3 in for y, and I'll put negative 2 in for x. Okay, that's negative 10/4 b, which is going to reduce to negative 5/2. Okay, and I'm going to add 5/2 to both sides. Before I do that, I'm going to rewrite the 3 as 6/2, right? So I have a common denominator, and then I'll add 5/2 to that. So b is 11/2. Okay, so if we go back to here, I knew it was y equals 5/4 x plus or minus something. Now I know that something is 11/2, so I can finish the problem. Okay. All right. So I wanted to illustrate the difference between these two equations. They're not quite the same. So if I'm finding f of negative 3, that just means I'm plugging in a negative 3 for the x, right? So let's plug it in and then start simplifying. So PEMDAS, I'd want to do the parentheses. Well, there's nothing to do in the parentheses. Then the exponent. So I'm going to take negative 3 times negative 3 would be positive 9 plus 1. So negative 9 plus 1 is going to be negative 8. Okay. All right, so let's take a look at this one. So this is a little different. Or actually, it's not different. It's going to turn out the same. Sorry, I shouldn't have put the equal there. I'll put it down here. So let's just start plugging this in. So okay, so positive 9 again over here. I remember why I confused myself. I thought I was trying to show a difference. Now I realize I'm trying to show that these two mean the same thing. You would still do the in this format. You're still going to do the exponent before the multiplication. It doesn't really feel like multiplication because there's just a minus there, but we are taking the opposite of x squared. And if you know what x is, you have to do the squaring first. You have to think of it like that, right? So when I plug this in, I put it in parentheses, and then it worked out the same as that one because we really got an exponent and multiplication. We're multiplying by negative 1 in these. So in PEMDAS, exponent comes first. Okay, that's it for that warm-up, and I'll see you next time.